We're going to solve inequalities. We'll just abbreviate inequalities. Remember, that's less than or greater than. And how we're going to do it? By adding or subtracting. We're going to solve inequalities by adding or subtracting. The goal is the same as it was when we did equations. And that goal is to get the variable alone. Get variable alone, all by itself. We'll do 4 examples. Here's our first one. If you remember, we have to use inverse operations. If it's plus 3, then we'll have to subtract 3. And we'll have to do that to both sides. Make sure you draw that line underneath. So that's going to leave us with x. And this is gone. And this over here, -4 and -3. We're just putting them together. They're the same sign, so add them up. 4 and 3 is 7. So that's -7. What do we do with this symbol here? Just bring it on down. And that is it. There is your answer. So just bring this symbol on down. Next, we're going to go ahead and graph our answer. Now, so go ahead and make a line, number line. And our answer is at -7. Our solution is at -7. So you know what? All I need is 0 and -7. -7 would be over here. Now what we're doing is we're graphing all the answers. Now first of all, notice there's a bar right there, so it's equals. So that means we're going to put a solid dot right there. Solid dot at -7. So I'm going to make a big solid dot because it's equals. So, because see, our answer could be -7 or less than. Less than or equal to -7. -7 is one of the answers. The other answers are less than -7. So that means it'd be going this way. There's more than one answer. There's lots of answers. And the answers are -7 and anything less than that. Okay, number 2, we have x minus 6 greater than -9. So we have -6. To get rid of -6, I would do the opposite, add 6. You have to do it to both sides. You have to be fair. So if I do that, that takes care of -6 and +6. That cancels. And you're left with just x. That just makes 0. And then I have -9 and 6. So they're different signs, so you have to subtract them. 9 take away 6 is 3, and there's more negative, so it's negative. What do I do with this symbol? Just bring it down. So the answer is, the solution is x can be more than -3. Can't be equal to -3, but more than. So any number more than -3 will work for this. So let's draw a number line next to it. And basically you only need 2 numbers, just 0 and -3. Okay, is there any bar there? No. So that means it's an open circle. So the answer can't be -3, but anything more than -3. So anything more than, so that would be 0, 1, 2, all those. Anything more than -3 will work. So here's a solution, and then here's a visual representation of that solution. Okay, we want x by itself, so we need to get rid of plus 12. To get rid of plus 12, I subtract 12. You have to do it to both sides, though. You have to be fair about it. So if I do that, that makes 0. Bring down the x. And then this is 16 minus 12 is 4. Bring down the symbol. So we have this. Now this is a little bit tricky, but we want x on the left side. So watch this. I'm going to put x on the left side, and I'm going to put 4 on the right side. Now if I do that, I am going to have to switch around this arrow, because it doesn't make any sense. 4 is less than x. Okay, so if I put it this way, I'm going to have x is less than 4. That doesn't make sense. So what you do is, notice how it's pointing to the 4? Point it to the 4. So if it switches sides, you have to switch over the arrow. And this is what we want to graph. This makes more sense to us. So x is anything more than or equal to 4. It can be 4 or anything more than that. So I'm going to make a number line and to represent this, and I'll have 0 and 4. I'll use that number 4. Okay, first of all, notice that there's a bar equals, so that means it can be 4. So it should be a solid at 4. So at 4, I'm going to make that a solid circle, solid dot. Also notice how it's pointing to the right. It's more than 4. Anything more than 4. Well, anything more than 4 would be 5, 6, all these going this direction. Then put a big arrow at the end because it keeps on going. So all these numbers will work. 4 and anything more than that. Also notice how it's pointing to the right. So you would shade to the right. Notice on this one it's pointing to the left, so it doesn't make sense to point it to the left. That would be wrong. That's why we put x on the left-hand side. It makes more sense to us. Okay, this is our last example. Okay, notice I have minus 3, so I need to add 3. Remember, I want x by itself. So I add 3 over on this side. And if I do that, that's gone. That's 0. You're left with just x. On this side over here, negative 8 plus 3. They're different signs. 8 take away 3 is 5, and there's more negative. And the arrow stays the same. Now we're faced with the same thing we did before. We have x on the right side. Let's put x on the left side. It makes more sense when graphing. So if I change sides, I'm going to have to change the arrow. See how the arrow is pointing to the x? Point the arrow to the x. So I'm going to use my number line again, 0, and that's at negative 5. So I'm going to use 0 and negative 5. Okay, notice that there is no bar. So we're saying x it's not negative 5, but it's less than negative 5. So if it's not negative 5, you have to put a circle there. Open circle. But it is anything less than negative 5. So it is all of this. And notice how if you have x on the left, you just shade with the arrow. The arrow's going to the left, you shade to the left. So this is the solution, and this is a display of the solution, all the answers it could be. So again, you found the solution and then you displayed it by graphing it. You did it by adding or subtracting.